Okay, today I am taking very interesting topic, that is Einstein theory of relativity. Everyone have heard about this theory, I hope. Okay, you can see picture of Einstein here. So there are two theory. Okay, basically in Einstein theory of relativity there are two theory. One is general theory of relativity. It tells about gravity. Okay, means it does not tally with Newton's law of gravitation. It's different than the Newton law of gravitation. Okay, it basically tell that gravity is the consequence of space-time curvature. Okay, and second one is special theory of relativity, E equal to mc square, time dilation, length contraction. This thing you have heard, I think. So this comes under special theory of relativity. Almost everyone has heard about E equal to mc square. Okay, now at first let us see general theory of relativity. We will not go detail in this topic, that is general theory of relativity is mathematical equation, mathematical form is quite complex, and I already said that it tells about gravity. Okay, it tells about gravity, okay, it is theory of gravity. Okay, tells about gravity, tells about gravity, it gives information about gravity. Okay, it explains gravity basically, you can see. So here is the statement: the general theory of relativity, also known as general relativity, is the geometric theory of gravitation. It is theory of gravitation which was published by Albert Einstein in 1915 and is the accepted description of gravitation in modern physics. In modern physics, we do not follow Newton's law. Means in classical we follow, but in modern physics we follow this theory of relativity to explain gravitation. Okay, now it describes gravity as a curvature of space-time caused by mass and energy. You can see this one, this fabric, you can see this is called the curvature of space-time. Okay, so basically this is all about general theory of relativity. It's quite complex topic, and the expression, mathematical form is also complex. And this was, see, yes, universe is accelerating, it is expanding, and expansion is accelerated, and this all thing is governed by this general theory of relativity. Okay, so regarding universe, or you can say cosmology, in the study of cosmology, general theory of relativity is very important. Okay, but day-to-day life it is not important. Means Newton law of gravitation is useful in day-to-day life, but for cosmology, in order to study the cosmology, universe, general theory of relativity is very, very important. Black hole, okay, stars. Okay, now but today we are going to discuss about special theory of relativity. Everyone has heard about E equal to mc square. Okay, this time dilation, length contraction, it comes under the special theory of relativity. Now see here, relativistic mass. This m naught is rest mass here. Okay, when particle is at rest, it is m naught. Now m is the relativistic mass when particle is in some speed. Okay, it almost relatable to the speed of light. So you can see here, basically here m, that is relativistic mass, is given by m naught by under root 1 minus b square by c square. Clearly you can see here, if there is significant value of v, then this denominator will be less than 1. So m naught divided by less than 1 will be greater than m naught. This means that m will be, this implies that m will be greater than m naught. Okay, so relativistic mass increases when velocity, speed increases, mass increases. So in relativistic mass is greater than mass increases. Okay, relativistic mass is greater than rest mass increase, you can see here. Okay, so this in particle physics especially, this is very important. See, cyclotron does not work in particle accelerator. Cyclotron is particle accelerator which does not work at relativistic speed, means speed comparable to the speed of light. That cyclone does not work due to decrease in frequency because of increment in mass. You can see this mass is increased. So synchrotron has to be built in order to accelerate the particle in relativistic speed. Okay, so there is the use of this thing. Okay, now let us move forward. Now fundamental principle, there are two fundamental principle. One, first is, it is the fundamental principle of special theory of relativity. Okay, these two principle. Second one, it's easy. You can see the speed of light in free space is the same for all observer in inertial frame. So it means that in free space, whatever velocity you move, means in a constant velocity, if an observer is moving, then the speed of light is constant, means light is a universal, speed of light is universal constant, that is c is constant. This is telling that c is constant. C is constant means even for the moving body, like if observer is moving or observer is rest, means all the inertial frame speed of light is constant. Okay, for observer moving in a constant velocity, means speed of light is constant. Now all the laws of nature, now first one let us see, all the laws of nature have, means laws of nature, or you can say laws of physics, have exactly the same form in all inertial reference frame. Means all the laws of nature have the same form in all inertial reference frame. Basically what one is telling is, what this principle number 1 is telling is, like let me give you one example. For this one, let me give you one example. Let us say two observer is there. Okay, one is inside the bus, let us say. Okay, and another observer is in the ground. He is on the let us say ground. He is here. Now this is at rest, it is in motion. It is in motion. This it is moving, it is at rest. But see, with respect to each other, if this is A, this is B, we cannot say that which one is in motion, because A feels that this B is going in backward direction. B is going in backward direction. With respect to A, this B is going in this direction. A feels like that. Okay, similarly B feels that A is going in this direction. So A feels that B is moving and B feels that A is moving. So we cannot say that A is moving and B is at rest, and B is moving and A is at rest. According to this first one, it is relatively, if you see, both are, means with respect to A, B is moving, and with respect to B, A is moving. Both are valid. Okay, this is what first principle. Now let us study time dilation. Okay, in this lecture basically I will discuss about time dilation. Dilation means time becomes longer, means time moves slowly, means time moves slowly. Okay, time dilation means time moves slowly, time is moving slowly, time moves slowly, moves slow. Okay, this is what time dilation. You can see here, Einstein theory predict that if a clock is moving, this statement you can see, Einstein theory predict that if a clock is moving with respect to an observer in an inertial reference frame, he will observe it to be running slower than clock at rest relative to the observer. Okay, one clock is at rest and one is moving, then that moving clock, that observer will see that moving clock is moving slower. Okay, this statement you may not understand beginning, but I will take one example later at the end of this lecture. With that example everything will be clear. Okay, don't worry. Now you can see here, right portion, you can see, let us derive the time dilation, this equation. Okay, now this is light clock. Okay, this is your light clock. Its length is L, length of this clock is L, length of this light clock is L. Okay, length of this light clock is L, and this is photo detector be P, and this is mirror be M. Okay, now in first case velocity is 0. In this first case velocity is 0. Now you can see that in this light clock what is happening, from here there is flash of light which will is emitted, and this flash of light will strike this mirror and then it gets reflected back to the detector, and this photo detector will detect the light and it will make sound tick. So as it ticks, then another flash of light is emitted. Means basically, see, light is flashed from this source and then it is reflected from this mirror and it will come back and comes to this detector, and detector detects, means it will tick. it will make tickling sound and then another flash will be emitted. Okay, so now let us see. We know that speed of light is c. Now this length is l, so you can write if t is the time, t is time, then if t is time, let us say t is time for a tickling sound. Okay, for a tickling sound or for a single tickle, or you can say for a single tick. Okay, for a single tick. Now you can see, as this length is L, this is almost L and L, so it will be you can say this implies that 2L is equal to CT. So it flash, so it reaches here L and again come back L plus L, 2L, and the time tick means from the first flash to the tick, another flash means time taken for a successive flash. It is how much? T, means at first light is emitted from the source, this flash, and then it tickles here, it makes tick sound, so this time taken is T. So 2L is equal to CT, where C is the speed of light. Everybody knows C is the speed of the light. Now in this second case, this clock, this light clock is moving. Okay, light clock is moving with speed v, you can see. Now let this be d, then this will also be equal to d. Now let time taken here be t dash. In this case let it be t dash, means in second case time from this this flash will strike here and then again come back to the detector, light detector or photo detector, you can say. So this time period is t dash. In second case, when this light clock is moving with speed v, then time for this tick sound is how much? T dash. In second case it is t dash. Now this is d. Okay, hypotenuse is d, here it is right angle, you can see. Now for second case, when clock is moving with velocity v, you can see t dash is the time taken by the light to reach the detector. If you see this picture, this d plus d, so 2d equal to ct dash. So clearly you can write 2d is equal to ct dash. So this implies that 2d distance travel in that time for the tick sound is ct dash. Now also if you see half v into t dash and half v into t dash, because vt dash, okay, this total is vt dash. From here to here it is, from here to here it is vt dash, so it will be half vt dash and this will be half vt dash. This basically this distance, this total distance is vt dash, means this speed is v and so time taken is t dash, so this will be vt dash. Very simple, you have learned in equation of motion. So this will be half vt dash, this will be half vt dash. So you can apply Pythagoras theorem. So d square is equals to half vt square, half vt whole square plus l square. So d square is equals to l square plus half vt dash whole square. D square is equals to l square plus 1 by 4 v square t dash square. So let us substitute, let this be a, this be b. From a and b you can write c square t dash square by 4, because d is equal to ct dash by 2, so it will be c square t dash square by 4 l square plus 1 by 4 b square t dash square. This implies c square t dash square by 4. For L square, you see here L square relation, you can see L 2L equal to CT, so L equal to CT by 2, so CT by 2, so you can write CT by 2 whole square plus 1 by 4 b square t dash square. Here you can see, from here you can see left, so 4 is get cancelled, so c square t dash square minus b square t dash square is equal to c square t square. So t dash square is equal to c square t square divided by c square minus b square. This implies that t dash is equal to t by 1 minus b square by c square. Okay, this is the equation for time dilation. This is the equation for time dilation. Clearly you can see here t divided by less than 1 is always greater than t, so t dash will be more. This t dash is the time that is observed by the observer in rest frame. Okay, observer in rest frame, what you will see, the time, what you will see, time taken by that moving object is more, means time is more, or for moving object time is moving slower. Now this is the equation for time dilation. Now let us see this question. So you will understand everything from this question. Okay, now here you can see pregnant lady, this is the way she need to travel to reach the hospital. You can see, let's assume that the speed of light is 100 km per hour. Here speed of light we have taken less in order to make it comparable with the speed of this car. Okay, speed of this car, so that equation of that relativity, that is field theory of relativity, will come into picture, or you can say we will have proper visualization of this equation. Now a pregnant woman drove herself at 80 km per hour to the hospital. She is driving in this speed which was 100 km away. So this distance is 100 km to reach this hospital. Now she also says that according to her watch, the baby was born 1 hour after she left. So baby was born means 1 hour after she left according to her watch. Was the baby born in the hospital? Now you can see. What do you think? You tell me. What do you think? You just think baby born in hospital or not? See, if we use our common sense, what we believe is this her speed is 80 km per hour and distance is 100 km. 80 km per hour means in 1 hour she can travel only 80 km. See, clearly you can see in 1 hour she can travel only 80 km. But distance is, but hospital is how much far? Hospital is 100 km far. It is 100 km far. So in 1 hour baby is born and she will cover only 80 km, but hospital is 100 km far. So we feel common, if we use common sense, easily we will feel that baby is not born in hospital. But what time dilation or special theory of relativity says, let us see. T dash is equal to t by 1 minus b square by c square, this root over. Now if you see observer at rest frame, inner cell frame, but which is at rest. What is the value of t? Time according to her watch is 1 hour, and 1 minus her speed is 80, and speed of light it is 100. 1 minus b square by c square. So this implies that t dash is equal to 1 by root over 1 minus 8 by 10 means 2 4s are 8, 2 5s are 10. So this implies that t dash is equal to 1 by 25 16 means 9 divided by 25 root over. This implies t dash is equal to 5 by 3. This implies t dash is equal to 3 1 3 4 5, so 3 6 18, so 1.67 hour. So this is as observed by rest frame. So for that lady she observed 1 hour, for according to rest frame it is 1.67 hour. So it means that time is moving slow. Its t is 1 hour and t dash is 1.67. We can say that time is moving slowly. Okay, this is the significance of special theory of relativity. So you may feel that biological time means that delivery time, maybe for that special theory of relativity may not work. But if special theory of relativity does not work for that biological time, then theory of relativity is violated. Okay, so special theory of relativity, it works for biological or this clock time, for all the purposes, means for everything in this universe. Special theory of relativity, this time dilation, it is valid. Okay, this is valid. So in 1.67, how much second travel, your speed is 80 into 1.67. so this is greater than, this is very greater than 100 kilometer, which is the distance of hospital. So baby will be born in hospital. So what you can say, baby is born in hospital, baby will be born in hospital. Okay, first principle that special theory of relativity, first principle says that I have explained that with the help of that bus and the person which is standing on the road, we cannot say that which one is moving and which one is at rest. So in fact each observer observes that the other clocks are slowed down by the same dilation factor. Okay, that length contraction also follows from the dilation only, so you can easily do for length contraction if you know time dilation. Okay, thank you. If you have any doubt, you can ask.